Hi everybody, welcome to Unit 6, Video 3. This is I can recognize and graph quadratic functions. Alright, so what we're doing today is we are graphing our quadratic functions or our parabolas. And so remember, the standard form of a parabola is y equals ax squared plus bx plus c. And what we need to do to find the starting point of any parabola is we need to identify the vertex. So the vertex is the starting point. And instead of calling the coordinates xy for the vertex, they are xy, but they're special. For the vertex, we call them h and k. So h is the x coordinate of the vertex, and k is the y coordinate of the vertex. So here we have in standard form to find the x coordinate of the vertex, which is called h, we do this formula. H equals negative b over 2a, where a and b come from here. They come from your quadratic. And then to find the y coordinate of the vertex, or k, plug h in for the x coordinate of the equation and solve. All right, so let's go ahead and do that. So remember, in order to start a parabola, you always start at the starting point, which is called the vertex. So first, I'm just going to identify a and b. So I have a equals the coefficient of x squared, when this case is 1. B is the coefficient of x, which in this case is 4. So now that I have those two things, I can go ahead and solve for h. So h equals negative b over 2a. So negative 4 over 2 times 1. So when I go ahead and simplify this, I get negative 4 over 2, which gives me negative 2. So now I need to go ahead and find k, which is the y coordinate of the vertex. So it says plug h in for the x coordinate of the equation and solve. So I'm going to plug it in here. So instead of writing y, I'm going to write k equals, because remember, we're saying k is the y coordinate, and we're plugging this negative 2 in for wherever we see the x. So negative 2 squared plus 4 times negative 2 plus 3. So then we want to go ahead and simplify. So when we do that here, I'm going to get 4 minus 8 plus 3. So then when I add all these together, 4 minus 8 plus 3, I get k equals negative 1. So now I want to go ahead and think of the vertex as a coordinate pair. So remember, it's h comma k, so it's negative 2 comma negative 1. And if you go ahead and look at the bottom of your paper here, there's a space on the bottom where you write the vertex. And so let's go ahead and write that as a coordinate pair, negative 2, negative 1. All right, so now what we're going to do is we are going to go ahead and plot negative 2, negative 1 right here, negative 2, negative 1. So this is our vertex, or our starting point. So now parabolas make this kind of U shape. And what's special about the parabolas is that if you cut through the vertex, they're symmetrical. So it means they're the same on both sides. Like if you have a mirror, it has a reflection point. So the next thing you notice on this list is called the axis of symmetry. Well, the axis of symmetry is that line that cuts your parabola in half. So it's what makes it symmetric. And the axis of symmetry is always a vertical line that goes through the x coordinate of your vertex. So if we were to graph that right now, it goes through like this, okay? And it's always a dotted line that goes through, a vertical line that goes through your x coordinate of your vertex. So since we know it's a vertical line, it's cutting through the x-axis. The equation for the axis of symmetry is x equals negative 2. Now you don't just say negative 2 because that would mean it's a point. It has to be x equals to identify that it's a vertical line. So the next thing we need to do is we need to start plotting some other points so that we can connect the dots and make the parabola. And so what you could do is you could find the easiest points to find are the x-intercepts and the y-intercepts if they have them. Remember, to find the x-intercept, you could plug in a, b, and c here to the quadratic formula and solve for your x-intercepts, or you could plug in 0 to find the y-intercept. You can plug in 0 for x and solve that way. That could work, but since we have graphing calculators, you could also do it on your graphing calculator. So if you go to your graphing calculator now, you're going to want to go ahead and hit y equals, And where you have y equals here, you can want to make sure that this is an equal sign, not an inequality sign. So if it is, you want to go to the over to the left and then make sure that you turn this one into the equal sign and just press OK. All right, so now that we have that, we're going to enter this equation. So the equation is y equals x squared plus 4x plus 3. So x is right here. We're going to do x, and then we're going to hit squared, which is right here, kind of by the 7. X squared, and then it was plus 4x plus 3. So now that I have my equation in here, if you wanted to graph it, you could just hit graph, but I'm concerned with this one that says table, because that's going to give me the table of all the coordinates. So right now, if I hit second table, I'll go ahead and I can see all of the x and y coordinates. And if you notice right here, -2, -1, there's my vertex. And if you start noticing, like if you look at the y values, see how they go 0, 8, 15? If you look below the vertex, or sorry, 0, 0, 3, 8, 15, then right here you have 0, 3, 8, 15. They repeat, and that's because it's symmetric. That vertex is your turning point. All right, so we can go ahead and identify from here some other coordinates to plot on our graph. So let's start with this one. We have -3, 0. So that means if I go right here, I can plot, -3 and 0. So -3, 0 would be here. I could also go the other way down here and plot -1, 0. So -1, 0. And if I notice them, these 2 points are my x-intercepts. It's where your parabola is going to cross the x-axis. I can also go ahead and plot, let's say, -4, 3. So -4, 3. And I can go ahead and plot 0, 3. And this coordinate right here, 0, 3, this would be my y-intercept because it's where your parabola crosses the y-axis. Now you can go ahead and plot some more if you wanted to, but I always like to have 5, the vertex plus 4 others, so 5 points. And then if you go ahead and connect your dots, remember you're going to make it go kind of like a U shape, and then it goes on and on to infinity, so it keeps going. And just if you wanted to see what it looked like, if you hit this button here, graph, it'll show you your parabola. So there's what the parabola, and it goes, ours looks this. Mine should have like a little bit more of a curve, but there's my sketch. Okay, so let's go ahead and go back to our chart here. This is saying the next thing they want to know is the domain and the range. Well, remember, the domain are all of your possible x values. It means if I plug a value in for x, will I get a number out for y? And so this parabola is going along your x-axis. That means if you plug a number in for x, like if you plug in 1, you're going to get a value out for y. If you plug in 2, you're going to get a value. If you're going to plug in 3, you're going to get a value out for y. And this goes on for infinity, forever and ever and ever. So that means the domain is -infinity to +infinity. Okay? Now the range, that's all of your y values, your y-axis. So that, and this one's different because it's not going to go to infinity. Because if you look right here, there's no values. If you plug in a value of -10 for y, you're not going to get anything out for x. You don't start getting y values until right here, until this point. So that means that your range of y values starts at the lowest y value. So you look on the y-axis, which is right here at -1. And then if you start going along the y-axis, you get values out for x along your parabola. So that means the range of y values is, it includes, or it starts at -1 and it goes on to +infinity. So it goes up. So if you go, you're starting at -1, then you get a number. So you start getting these numbers out to plot on your parabola. You're getting y values. All right, this is asking if it's a minimum or a maximum value. Meaning if you look at the vertex, you want to say, okay, is the vertex at the bottom or is the vertex at the top of the parabola? In this case, since the vertex is at the bottom of the parabola, that means your parabola has a minimum value. And we always say it's a minimum value of y at x. So in this case, we say minimum, I'm going to abbreviate, value of y. So the y coordinate is -1 at x equals -2. So it's a minimum value of -1 at x equals -2. So that means here, so the smallest value that y can be is when -1 when x is -2. All right. So the next thing is we write our x-intercept, and since we solve on the calculator, we saw where the value of x, or where y was 0 to find the x-intercept. You could have also done it by doing the quadratic formula. That would have worked too. But we used the calculator, and so we found that our x-intercepts were the coordinates -3, 0, and then it was also right here at -1, 0. So right here, where our parabola across the x-axis. Those are the x and y intercepts. The x-intercepts. Okay, so the y-intercept, where the parabola crosses the y-axis when the value of x is 0. And we said it was right here at this coordinate. So the x-intercept here is 0, 3. All right, so let's go ahead and go to the next one. You'll notice something a little bit different about this. This one here, now your coefficient of x squared is -2. So kind of think about, what do you think that's going to change? Here, the coefficient of x squared was a +1, and we had this parabola that opened up in the positive direction. So if you take a look, try to think, what do you think is going to happen when this one is -2? Okay, so I want you to pause the video and see if you can walk through all the steps. Also, I want you to try to see if you can do it on your graphing calculator to help you find those other coordinate points. Okay, so let's go ahead and take a look at how you did. So remember, the first thing we have to do is find the vertex. So you have to identify A and B. So remember, we're looking for H. H is -b/2a. So here's what I plugged in, and then when I simplified, I got -1. Remember, to find K, or the y coordinate of the vertex, you plug in -1 to where you see x on your equation, and then K, since it's the y coordinate, plug in, you substitute with K, and then you plug in and you simplify, and here I also got -1. So my vertex here is -1. -1, -1. So I plotted it here, and then my axis of symmetry always goes through the x coordinate of your vertex, and it's a vertical line. So since it's this vertical line, it's x equals -1. All right, so now I plugged everything into my calculator, and so when I plugged it into my calculator, here was my equation, y equals -2, x squared minus 4x minus 3, and when I graphed it, I noticed it went upside down, and it doesn't touch the x-axis. So that means there are no x-intercepts, right? So if I go here to, when I hit second graph, I get my table of values. And you can see, here's -1, -1, so that was my vertex. And then if you notice here, the points start going back and forth because it's symmetric. So I always like to plot at least the vertex in 4 other coordinate pairs. So the next one I chose here was -2, -3. So if you go over here, -2, -3, you can look on your calculator, or since you know the axis of symmetry, since this is 1 unit away from the axis of symmetry, you could always go 1 unit away on the other side and get your reflection point. Same thing here. If you did -3, -9, same thing, you could go, this is 2 over from your axis of symmetry, so you could go 2 over from your axis of symmetry and have your reflection point and connect all your dots. Or you could have just looked on the calculator and found all of the other coordinate pairs, okay? So this one, let's go with the domain. So you're saying, look along your x-axis. If I plug in an x value, will I get out a y value? So if I plug in an x, will I get out a value for y? And this one is yes. And since this goes all the way to infinity, you can plug in all these x values and get out values for y. So your domain is -infinity to positive infinity. Now the range, if you look along your y-axis, that's not the case. Because if you look up here, if you plug in a y value, you're not going to get anything along the x until you get to here. So that means the first y value you see is -1. But this one's a little bit different since this is upside down, and we always read the number line least to greatest. Your eye has to start here at the bottom and goes all the way to this point, which means this bottom, all of this here is -infinity to -1. So your range is negative infinity to negative 1. All right, is it a maximum or minimum? Well, we have to look at the vertex. So since the vertex is at the top of your parabola, that means it's the maximum it can go. And it's of y at x. So we say we have a maximum value of negative 1 at x equals negative 1. So the maximum value of y is negative 1 when x is negative 1. Since this parabola doesn't cross the x-axis, there's none or no x-intercepts, and the y-intercept, which we found on the calculator, but you could have also plugged in 0 for x and simplified. It crossed right here at 0, negative 3. All right, let's go ahead and go to the next one. So this one is asking you to practice now. It's saying identify the vertex, axis of symmetry, domain, terrain, x and y intercepts, and the maximum min value of each. Then sketch the graph. All right, so here's 2 more. So you could probably already tell, since this coefficient is positive, we know it's going to open upwards. Since this coefficient is negative, we know it's going to open downwards. Okay, so go ahead and pause the video, see if you can walk through all of these, and then we'll take a look at it. Okay, so let's go ahead and go to number 1 here. So when we go ahead and plug in, remember we identify A and B, and h is negative b over 2a. So when I went ahead and plugged in and solved for h, I got 1. And then to find k, remember, k is the y value, and then you plug in this h value here for x, and you simplify. So then when I simplify, I got my vertex was 1 and negative 4. So then my axis of symmetry, remember, goes to the x coordinate of your vertex, and it's a vertical line, so it's x equals. Then when I plugged it into the calculator, I found my x-intercepts. So it crossed here, and so my x-intercepts were negative 1, 0, and 3, 0. Again, if you didn't have a calculator, you could always plug a, b, and c into the quadratic formula and find your x-intercepts, or your roots. To find the y-intercept, if you didn't have a calculator, plug in 0 for x and solve for y. So in this case here, when I did it on the calculator and I got my y-intercept right here at 0, negative 3, since the vertex is at the bottom, it means it's a minimum value of negative 4 at x equals 1. Remember, it's always of y at x. And then the domain, again, if you look along your x-axis, if you plug in a number for x, you're going to get out a number for y along your parabola. So it's all real numbers, or negative infinity to positive infinity. And my range, again, if I look on the y-axis, I start here at negative 4, and then it goes all the way up. So it's negative 4 to infinity. All right, so if we go to number 2, again, identify A and B. So H, we have to solve for H first. So I plugged it in, and I got negative 3. Then I substituted in to solve for K, and I got 1. So then here was my vertex, negative 3, 1. So I plotted negative 3, 1. Then I drew my axis of symmetry. So through the x-coordinate, so x equals negative 3. Again, once I found my x and y intercepts, I got negative 4, 0, negative 2, 0. And my y-intercept was all the way down here, so I went ahead and plotted that point. I know it's more than 5 points, but that's fine. I wanted to plot the intercept. And then I also went and found its reflection point. And so here, the y-intercept is 0, negative 8. Since the vertex was at the top of your parabola, this is a maximum value. So it's a maximum value of 1 at x equals negative 3. Again, the domain, if I look along the x-axis, it would be all real numbers. My range, remember, your eye starts from least to greatest. These are the negative numbers, so you're starting at the bottom and stopping here. So it's negative infinity to positive 1. And so something you may have noticed on all of these problems is the domain was always all real numbers. That's because your parabola is open along your x-axis. So anytime you have a parabola like these, where it's opening along the x-axis, your domain will always be all real numbers, but your range will be something else. If you've noticed, they've always been something else, okay? All right, thank you for watching the video.